Every time you call an LLM API, the model rereads your entire system prompt. Every single time. That 2,000 token system prompt you carefully crafted, processed fresh on every request. Those 50 tool definitions, reparsed from scratch. This is costing you a fortune, but there's a fix: prompt caching. It can cut your API bill by up to 90%. Let me show you exactly how it works and how to implement it today. The concept is beautifully simple. The provider stores the processed KV cache from the attention mechanism for your shared prefix. When a new request starts with the same prefix, it loads the cached state instead of recomputing it. Request 1 processes the full 2,050 tokens at full price. Request 2, only the new 50-token user message gets processed. The cache matches from the beginning of the messages array. As long as the prefix is identical byte for byte, the cache hits. Same system prompt, different user question, cache hit. Change even one character in the system prompt, cache miss. Let's start with Anthropic. They were first to make caching explicit and developer-controlled. You mark which parts should be cached using cache control. Here's how. You add a cache control field with type ephemeral to your system message. The first call is slightly more expensive because of the cache write fee, but every subsequent call is 90% cheaper on cached tokens. By the third call, you're already saving money. The math is overwhelmingly in your favor. OpenAI takes a completely different approach: automatic caching with zero developer action required. No cache control, no explicit. Just make normal API calls and OpenAI detects repeated prefixes and caches them automatically. Here's the key difference. Anthropic gives you 90% savings but requires developer effort. OpenAI gives you 50% savings with zero configuration. It's a trade-off between control and convenience. Now let's talk practical patterns. Pattern 1, cache your system prompt and tools. This is the most common pattern. Your system prompt and tool definitions are identical across all user requests, making them perfect for caching. Pattern 2, cache RAG context. If multiple users ask about the same document, cache the document content and only vary the question. Pattern 3, cache conversation history. In multi-turn conversations, the history grows but the prefix stays the same, so each new turn reprocesses less content. Pattern 4 is critical stable prefix variable suffix. Structure your prompts so stable parts come first. Long instructions, then tool definitions, then dynamic content like today's date or user info. Anything before the first change gets cached. Anything after does not. Let's talk common mistakes. Number 1, putting dynamic content at the start. If you prepend a timestamp to your system prompt, the cache breaks every single second. Move it to the end. Number 2, randomizing tool order. Shuffling your tool definitions changes the prefix every time. Sort them consistently instead. 2 more gotchas. Cache TTL. If requests are more than 5 minutes apart, the cache expires. For low-traffic apps, caching won't help much. And minimum size, Anthropic needs at least 1,024 tokens to cache. A 200-token system prompt simply won't be cached. Always monitor your cache hit rates. Both Anthropic and OpenAI expose cache metrics in their usage responses. A healthy application should see 60 to 90% cache hit rates. Below 30%, your prompts probably have too much variable content in the prefix. Here's your action plan. Put stable content first, system prompts, tools, reference docs, then dynamic content last. Use Anthropic's explicit cache control for maximum 90% savings. Or let OpenAI handle it automatically for 50% savings with zero effort. Either way, you're leaving money on the table if you're not using prompt caching today.